Okay, so in the last case, we saw that we can get two distinct roots. Then the life is so much easy. But how about if you happens to factorize your auxiliary equation to be like m minus 2 square equal to 0. So there's only one root. Okay, so we have the root 2, but its multiplicity is 2. That means you have the root repeated 2 times. Then you can only possible solution you can get is e to the 2x, right? E to the mx. You have only m1. Now since you don't have m2, then how are you going to find that second solution? Because a fundamental set of solution for a second order differential equation, you should have two solutions, two pieces. But you only get one piece if you have a repeated root. How to find the second piece? Can you remember something? Isn't that what we did in last section? Reduction of order method. I know a one solution. Can I find the second solution? Yes, right? So if you happens to have a repeated root, you have to use reduction of order method. And let me show you a fantastic result. Okay, that makes your life so much easy. All right, so let's assume that you only have a one root which is named as e to the m1x, right? You cannot find m2. All right, now the reduction of order method says you know a one solution y1. We assume second solution to be what? Remember? U times the first solution, u times e to the m1x, right? Okay, now what we do is we substitute this into the differential equation, right? Okay, let's do that. But to do that, we have to find y prime. So y prime means if you differentiate this, what do we need? Product rule. So u prime e to the m1x plus now m1 u e to the m1x. Now, is that enough? No, we need the second derivative. So if we use the product rule here, u double prime e to the m1x plus m1 u prime e to the m1x. Here, if I use the product rule, m1 u prime e to the m1x plus m1 square u e to the m1x. So we get y prime and y double prime. Now I'm going to substitute them into the differential equation. So now I'm not going to do that here in this video. Okay, so let's say we substitute all these three into the differential equation here. So this is what I get. Now you know, when I substitute them, we should be able to simplify, right? You saw that in the reduction of order method, you will be able to cancel certain terms. So it turns out when you cancel them, what you get is really a2 e to the m1x u double prime. All the other terms cancel out. You can do it as an exercise, okay? All right. So then this is really, we can divide by a2 and e to the m1x. We can divide, then it's just this differential equation is u double prime equal to 0. The easiest, right? Now what we can do? We do a substitution, right? Remember, we assume w to be u prime. So then u double prime mean w prime, right? So we get w prime equal to 0. So w prime means dw over dx is equal to 0, right? So now we can integrate both sides by separation of variables. We can take like this. And if we integrate just like here, if you integrate 0, you get a constant. So we get w to be c1. C1 is an arbitrary constant. Now what did we do? We thought w is u prime. So u prime is actually c1. W is u prime. So now we can solve for u by integrating this. Now if you integrate c1 a constant, what do you get? U is c1 times x. If you integrate c1, you get c1 times x plus another constant c2. Now we know for our simplicity, we can choose our own constants, right? When we do the reduction of order method. So let's choose c2 to be 0 and c1 to be 1. What is u? U is x. Great. So now what is the second solution? Remember, second solution we said it's u times e to the m1x. Now what is u? X, right? So this is the second solution. Now what am I getting here? what I'm up to here. So let me explain. So we did this reduction of order method. Me show you the secret. Okay, here's the thing. When you have a repeated roots, it's no secret that you only have a m1. So you know one solution, y1 is e to the m1x. Now what is the second solution? The secret is second solution is your previous solution times x. And you don't need to use reduction of order method. If you get a repeated roots, you don't have to show it. Okay, once you get the first root, you can write the second solution as x times e to the m1x. Okay, and these two are two linearly independent solutions. So the general solution is c1 e to the m1x plus c2 x e to the m1x. Okay, isn't that easy? Yes, so it's all about again factorizing, right? Now I explain how I got the second solution, so keep that in mind, right? That is for your learning. But when we go to solve the problems, we don't show reduction of order method every time, because we know every time it will be x times the first solution. Okay, just for this case, okay, not in every reduction of order method. Okay, only if you get a repeated root question. Okay, auxiliary equation. All right, so let's look at some examples. Y double prime plus 2y prime is plus y is equal to 0. So this differential equation, we can substitute y is equal to e to the mx, y prime and y double prime. So we get y double prime is m square e to the mx. Now you have to show this, okay? M e to the mx, just like the same normal, we substitute, right? We assume y to be e to the mx. All right, so we factor out e to the mx, we get m square plus 2m plus 1 equal to 0. We know e to the mx is never 0. So our quadratic function or the auxiliary equation is this. Okay, what is the factor? What do we get if we factorize this? We get m plus 1 square equal to 0. Okay, how many roots we have? Just a one, right? Repeated 2 times. What is the root? m1 is -1, but repeated 2 times. So what is the solution? One solution is e to the -x, of course. What is the next solution? X times e to the -x. Isn't that easy? Yes. Okay, so general solution will be c1 times e to the -x plus c2 times x e to the -x. Okay, all right, let's do one more example to summarize this. Okay, what is the approach again? You treat it like a normal problem. Okay, you don't predict on roots, right? Until you factorize, you don't know what's going to happen, whether it's distinct root, repeated roots. Later we are going to learn complex roots. You don't know that. What we do first is we assume y is equal to e to the mx. Then y prime is m e to the mx. Y double prime is m square e to the mx. Now you substitute them into the differential equation. Okay, so y double prime is m square e to the mx plus 4 times m e to the mx plus 4 times y is e to the mx equal to 0. Now you factorize e to the mx. So we get m square plus 4m plus 4 equal to 0. Now e to the mx is never 0. So we get m square plus 4m plus 4 equal to 0. The auxiliary equation. So what do we get if we factorize this? M plus 2 square, right? You have to be sharp in factorizing here. I'm not going to show how to do the factorizing. We did that practice, okay? If we factorize, we get m plus 2 square. Okay, what is the root? -2, right? Not 2, -2. So m1 is -2. So what are the solutions? First solution is e to the -2x. What is the next solution? X times e to the -2x. General solution is the linear combination of both of these linearly independent solution. So yx is c1 e to the -2x plus c2 x e to the -2x. Okay, all right. Yeah, so that is how you treat a repeated root problem. Thank you.